So we are going to be working on 13C and 13D. Today is about us learning to graph exponential functions and us also learning to solve exponential equations. So a exponential equation. The first thing I want us to think about is, let's get this pen, laser pointer, is our power. So if we make x 0, anything to the power of 0 is always going to be 1. That is why on our y-axis, it's going to cross over at 1. Likewise, when we've got a that is that is greater than 0 and less than 1, it is still going to be crossing here at 1, but our graph is just flipped. So one of the things you'll notice with an exponential function is that our domain is all real numbers, and our range is always going to be all positive real numbers. So there is an asymptote right here at y equals 0. So we've got a vertical translation. So vertical translation just means it's going to be pushing it up or pushing it down. So if we have our intercept at 1 and I add a 3, 1 plus 3 is 4. It's now going to cross over at 4. I had a asymptote originally at y equals 0. That's now been pushed up to y equals 3. Horizontal is going to be affecting our movements left and right, which is focusing on our x. So that's the part we need to be thinking about. So we we know that when our power equals 0, our answer is just going to be 1. That's crucial. So here we've got takeaway to x takeaway 2. How do I make that power 0? X must be 2. If x is 2, my y value will be 1. So that is the key point that we are going to use. Of course, there's the asymptote that is still staying at y equals 0. Now, if we are solving this, I'll be going into that after, but we can use our understanding of the y-intercept must have an x of 0. So all I would do is put 0, take away 2 is negative 2. Let's get a pen. Where is it? Pen. Um, so that means I would have 2 to the power of negative 2, which that is the same as me saying 1 over 2 squared, which is 4. So that means when x is 0, y is a quarter, which is what I've got here, 0.25. Reflection in the x-axis. So this part here is gives me my y value. If I wanted to do a reflection, then I put a negative here, and then this y value becomes a negative. So our intercept before was at 1, so now it's just going to be at negative 1. Everything else is identical. Reflection in the y-axis, same thing, but to get a reflection in the y-axis, we need to be focusing on our x. So if we had x of 2, to make that negative, we just put a negative on it. So wherever our x is, we are putting a negative and it flips. Our intercept will be the same and our asymptote will be the same. Dilation. So dilation is talking about stretching. So we are going to have here a vertical stretch. So a vertical stretch means I am pushing away from the x-axis. So because of a to the power of x is my y, and then I'm timesing it by the c value. So if c is greater, say I had it as 1, if I times it by 2, it will be 1 times 2 is 2. If I times it by 3, which I've got here, 1 times 3 is 3. So I'm pushing away from that x-axis. But if that value I'm timesing is less than 1, it means that it's going to be getting closer. So if I say a half, 1 times a half is a half. So it's getting closer to my x-axis. So you can either think about it as a vertical stretch, or you can think about it as pushing away from the x-axis. Likewise, if I've got dilation factor of the x-axis, it means that I've got horizontal compression. So that word should be horizontal. I'll fix it up on the PowerPoint later, but that is just horizontal. So it means that we are pushing away from the y-axis. Okay, guided practice. So we are going to start graphing. So we've got y is equal to -5 times 4 to the power of x. So the first thing we need to be thinking about here is I want us to state the transformations. So straight away, if I think about Dr. T, dilation, reflection, and transformation, I can see I've got a takeaway, so negative sign, which is a reflection. So a reflection in the x-axis, because my y value is going to be changed, and put a negative there. The next thing I need to think about is the dilation of 5. And this 5 is focusing on, this is my y value, and then I'm timesing it by 5. So I'm pushing away from the x-axis. The next, state known points. So we've got our y-intercept is going to be, so a y-intercept will always be when x is equal to 0. So that means if x is 0, I've got 4 to the power of 0, which is 1. 1 times -5. Our asymptote is still going to be y equals 0 because there is no vertical movement. So from this, I'm able to draw my graph. Okay, next question. We've got graph f of x is equal to 4 times 0.5 to the power of x plus 1. So the first thing I want us to do is state our transformations. So this 4 is referring to the dilation factor of 4. This is 4 is changing our y value, it's pushing it up by 4, which means, and that just means that we're pushing away from the x-axis. This 1 is referring to the vertical shift up. The next thing we need to be thinking about is our y-intercept and our asymptote. So our asymptote was originally at y equals 0. It's been pushed up by 1 to y equals 1. Our y-intercept, again, our y-intercept is when x is equal to 0. So if I put anything 0, it gives me 1. So 1 times 4 is 4, plus 1 is 5. The only other part we need to understand is our base. So because we have a base that is less than 1 and greater than 0, we need to be thinking about it so terrible basic graph there. I'll use black. We need to be thinking about it if my graph goes this way. So based on that, I know how it's going to look. I know my intercept. I'm then able to draw it.